triangles. An acute triangle, all angles are under 90 degrees.
What does it add up to?
Triangles all still add up to 180. It's just that in an acute triangle, every angle is less than 90. Okay, an equiangular triangle, okay, in an equiangular triangle, every angle is 60 degrees. And an obtuse triangle, you have one angle is greater than 90.
Why isn't it just called equilateral?
Yeah, that is true. Yes? Hi.
Hi.
And then in a right triangle, exactly one angle is 90. Okay. Now, the reason it can only be one angle greater than 90 degrees is because the triangle is 180 degrees, right? So you couldn't have two angles more than 90 because then you'd be more than 180. So it can only be one angle that's greater than 90 and only one angle that would be equal to 90 in a right triangle. We're going to classify these. I have three 60-degree angles. So that one's equiangular. I have a 40, a 45, and a 95 obtuse. 90, 50, 40. 80, 50, 50. 30, 50, 100. And finally, triangles have all sides the same length. Now, if you're equilateral, you're also equiangular. So equilateral triangles are equiangular, and equiangular triangles are equilateral. They're the same, yeah. If you're isosceles, two sides are the same length. And if you're scalene, no sides are the same length. Okay, so an equilateral triangle, and pretend I drew that correctly, they would have all three sides the same length. Isosceles, two sides are the same length, and scalene is no sides are the same length.
Do we have test pad?
We're going to look at these triangles that are kind of smushed together, and we're going to classify them as equilateral, isosceles, or scalene. Okay, so first let's look at what we have. This one is labeled with an 8. So that means that every other one of these are also 8.
Oh my god, this is getting hard.
Okay, now let's look at ABE. That's this triangle. Let's highlight it. So 7 is ABE. That's this triangle right here. It's, yeah, none of the legs are the same length, so it's scalene. Okay. If we look at triangle EDB, that's E and B and D. I have an 8 and another 8, so it's isosceles. We'll go with pink. EBC, that's this triangle. Ooh, that looks horrible. Okay, well, this triangle right here, I've got an 8. This whole side is how many? 16 and an 8 square root of 2, so none of them match. So we're scalene again. And then finally, go with blue. I've got DBC. Yeah, equilateral. Algebra. Isosceles. AB is congruent to BC, so this is AB and this is BC. That means these two sides are the same length. So I will set those equal to each other. And then I will solve the equation. And now you'll notice I'm not using that third side at all because I don't know anything about it. I just know that the two sides are the same. Add 3. And then finally divide by 2. And I have x equals 8. Okay, or 4. So I found x. I did this part. But it says, and the length of each side. So I'm only part of the way done. So this is like a 4-part problem. I've done 1 part. So, oops, wrong pen. AC is x plus 2. X was 4. So AC is 6. So this side 6. AB is 4x minus 3. So that's 4 times 4 minus 3. Right here. X is 4. So we did the x plus 2 and we replaced the x with the 4. So this side is 13. Now do I have to actually solve this side? No, because it's also going to be 13 because I knew that these two are the same size. So this also equals BC. If it's equilateral, what do I know about the 3 sides? So I can pick any 2.
4x plus 1 and 3x plus 10.
Okay, so we'll do that first. Okay, I'm going to subtract 3x from both sides. If x plus 1 equals 10, x equals 9. Okay, so I found x and now I need to find the length of each side. How many of these do I actually have to do?
1.
1, exactly. Which one you want to do?
4x plus 1. So easy.
So 37, 37, 37. Okay, so we'll plug those into the distance formula. So I get negative 5 squared plus 1 squared. 25 plus 1. So that's the square root of 26. You can stop there. You don't have to simplify these. You just need to know the distance, and the distance can be square root still, because we're trying to find length. Okay, then we can try PL. And we get 2 minus negative 2 plus 1 minus negative 3. So that's 2 plus 2 and 1 plus 3. So I have the square root of 4 squared plus 4 squared. So 16 plus 16. So the square root of 32. And the final side is KL. So negative 3 minus negative 2 squared plus 2 minus negative 3 squared. Again, these minus negatives are positives. Yeah, so I have negative 3 plus 2. That gives me negative 1 squared plus 5 squared. So 1 plus 25. Square root of 26. So here are my 3 side lengths.
Right there.
plus 16. Sorry, make that clearer. Okay, here's my 3 side lengths. 2 of them match. What kind of triangle is this? Isosceles. Triangles add up to 180 degrees, always. So how do I find angle 1?
You take 180 and subtract it from 153 or that.
Right. Or yeah, 153. So I'm feeling lazy.
It's 27.
I don't know. Like I said, I'm feeling lazy. It is, it's 27 degrees. Okay, here I have angles 1 and 2 are the same length. So 180 minus 146. So that's 34. But that's for both of them. So I divide it by 2. Okay, what do I know about angle 1 and 2? They're the same, right? So it's their vertical angles. I don't know. So first I can find angle 1. Right, so 180 minus 85 is 95. 95 minus 40 is 55. Did everybody agree? Okay, so angle 1 is 55. Well, angle 2 and angle 1 are the same. And then to find angle 3, I'll take 180 minus 55 minus 55. So that's 180 minus 110, which makes it 70. Because we have these external angles. What do I know about angle 1?
Angle 1 is the supplementary angle to angle 55.
Well, remember, angle 1 is equal to 70 plus 55. They add up, right? So angle 1 is, because this is the exterior, this was the remote interior angles theorem, where angle 1 is equal to the 2 angles on the opposite side added together. So angle 1 is 70 plus 55, which is 125, yeah? Angle 2 is going to be the same, 55. Now, angle 2 plus angle 3 will equal 150. So angle 3 is equal to 150 minus angle 2. Whoops, that's not what I meant, right? So 150 minus 55, so 95 degrees. Angle 1.
Is 60 plus 80.
Still on page 45. Yeah. Angle 1 is equal to 60 plus 80, so that's 140. Angle 1 and angle 2 are not the same. These two are the same, right? But angle 1 and angle 2 will add up to 180 because they make a straight line. So angle 2 is 180 minus angle 1. Well, that looks like 41, doesn't it? So that's 180 minus 140. So that's 40 degrees. Angle 3 and angle 2 add up to 105, 105, right? So angle 3 is 105 minus, whoa, I don't know what just happened there. So that's 105 minus 40, 65. Angle 4 and 105 add up to 180. And then angle 5 is angle 4 and 4. Yeah, so. If this is 90, what's this one? 90. So I can find angle 1 because I have 90 and 63, and angle 1 add up to 180. So angle 1 would be 180 minus 90 minus 63. So that's 90 minus 60 is 30 minus 3 is 27. So that makes this 63, right? If this is 27, that's 63. So angle 2 is 180 minus 90 minus 63. Hey, look at there. Interesting, don't you think?
Why is it interesting?
This is on congruent triangles, and congruent means same size, same shape.
Sounds familiar.
So all measures are equal. So if I have congruent triangles, this angle and this angle will be the same. These angles will be the same. These angles will be the same. This side will be the same as this side. These sides will be the same, and these sides will be the same. And that'll be true if I took this second triangle and I like rotated it around, but it had the same markings. The same number of loops means they're the same angle measure. The same number of little dash marks means they're the same length. Congruent corresponding parts. So this is on page 48 or 46. Yeah. So we have these two triangles. Angle J is congruent to angle T. Oh, right, you're right, page 47. Thank you. Okay. Angle P is congruent to angle V. And angle L is congruent to angle S. JL is congruent to TS because they have the same number of hash marks. JP is congruent to TV. And PL is congruent to VS. That means that triangle JPL is congruent to triangle TVS. Now this is important. J and T are congruent, so I have to put those in the same spot. P and V have to be in the same spot, and L and S have to be in the same spot. I couldn't say JLP is congruent to TVS because the order of the letters tells me that which angles are corresponding and congruent. So this tells me that these are congruent, and those are congruent. So if you switch the order of the letters, it's no longer a true statement. Does that make sense?
Did you say LJP and STV?
Yes. As long as the letters are in the same spot as their corresponding part, like that's congruent, you can put them in any order, but they have to be matching. Does that make sense? Yeah? Okay. All right, we go to the next triangle. I have angle, here here, but they're like, I can't use just the letter for a lot of these. Because if I say angle B, I'm talking about what angle? So I'm going to number these. Makes it easier, right? Okay, so I'm going to say angle 1 is congruent to which angle? Okay, angle 3 is congruent to, and angle E is congruent to angle G. Okay, side DE is congruent to DE is congruent to DG.
Oh, I thought it was G.
GF has 2 lines, DE has 1. Okay. EF is congruent to GF. And DF is congruent to itself. Because it's the same line, right? So that third side of the triangle is the same. So now when I put these in order, I have to be really careful. If I say DEF, what order do these go in? DGF. Perfect. Oops, I need to put the triangle symbol there. Okay, so because that tells me D is corresponding to D, E is corresponding to G, and F corresponds to F. Congruency to solve. Find the value of X. Okay, so I have B and D are the same. C and E are the same, so that makes A and F the same, right? Because triangles add up to 180. So that makes A congruent to F. Right? So that means, well, I need to find X. But before I can find X, I'm going to have to know what Y is, aren't I? Well, what's Y? Yeah. Okay, so you have to find Y first. This has to be accomplished first. Now I need to know what to set this equal to. So I have to find A, don't I, to know what that number is? So I have to find angle A, which is 180 minus 108 minus 48. Okay, so 180 minus 108 is 92. Right, let me just make sure I did that in my head correctly. 72, no, yes, no. Okay, 72. See, I didn't do it in my head correctly.
Makes sense.
So that's 24 degrees, right? So this is 24, which makes this 24. So if 2x minus y equals 24, well, I don't know what x is, but I do know that y is 48. My pen is dying. So 2x equals 72. Which makes x equal to 36. So first we had to find y, then we had to find a, then we could find x. We are going to write a proof. So we have statements. And we have reasons. Okay. What is our first statement?
Given that AB to
Okay, but we have, look at this, 1, 2, 3, 4 statements that are given. Just put my lines in there. What is going on with my pen? And angle ADB is congruent to angle CDB. Okay, so those are our given statements. I'm going to go ahead and label this. AB is congruent to CB. AD is congruent to CD. ABD is congruent to CBD, so ABD, so that's this angle. CBD is this angle. And then ADB is congruent to CDB, so that's these angles. Okay. Now, I want to prove that the triangles are congruent, which means I need all 3 sides to be the same and all 3 angles to be the same. I've got 2 of the sides. What do I know about this side? It's congruent to itself because of y. If you're equal to yourself, you're... There's property, reflexive. BD is congruent to itself. That's the reflexive property. Anytime you're equal to or congruent to yourself, it's reflexive. Okay, so now we have that this side, so we have all 3 sides. What do I know about angle A?
AB
Was equal to 180. I'm going to go ahead and label these 1, 2, 3, and 4 for now. Angle A is equal to 180 minus angle 1 minus angle 2.
ABD is congruent to CBD is what we're trying to prove.
Mm-hmm.
We wrote it down as given. Oh, wait a second.
No, I didn't. I wrote the angles down. Okay, that's just subtraction. Or actually, it's not subtraction. I'm sorry. That would be the,
linear, whatever.
no, triangles. Because triangles add up to 180 degrees. And angle C is going to be 180 degrees.
So would that be a definition of a triangle?
Yeah, you could say definition of triangle probably. And angle C is 180, so you could, we'll say definition of triangle. Sure, why not? Now, what do I know about 1 and 3? Or sorry, not 1 and 3, 1 and 4. 1 and 4 are equal, right? And 2 and 3 are equal. So I'm going to come over here. I ran out of room, sorry. And I'm going to say that angle C is equal to 180 minus angle 1 minus angle 2 because I'm going to substitute. I'm substituting 1 and 2 for 3 and 4 because they're the same. Okay, and we already know they're the same because it was given. So now angle A is congruent to angle C from substitution. Because if they're both equal to the same thing, they're equal to each other. And if I have all 3 sides are the same and all 3 angles are the same, I have congruent triangles. Okay,